These are the OS recovery tools. Let's take a look at the current emergency evaluator. So in Faro, when we evaluate an expression which is erroneous, which throws an error, we normally get a debugger, like this. So the question is, what happens when the debugger is broken? So I will open this open debugger method from the Morphic UI manager, and I will add an error just to break the debugger. Sometimes when you break the debugger and you try to get the debugger, this is the emergency evaluator, a really limited tool that we have in Faro. So let's see how the OS emergency kernel works. So instead of opening a normal Faro image, we will open a Faro image with an emergency kernel. An emergency kernel is actually another image, a complete image, that contains the other one and can control it. So we are coding just as always. We can throw a debugger like before, but if we break the debugger like before, so we put the error, we save the method, and we try to launch the debugger again, we go to this emergency kernel. The emergency kernel is a complete image that can manipulate the image that we were working on that is now broken. So what we can do there is to take a look at the source code of the method that we were touching. So if you see, we are looking at the open debugger and there's the self error there. So what we will do is to take the source code, remove the self error, and recompile the code to get a new method and install it into the class that it belongs to. And then we will restart our original image. Once we do that, we return to the original image and we see that the open debugger method is changed. It is the one we changed, and if we launch the error, we have again a debugger. Another interesting use case is when we do break an image. So I will open a normal Faro image, which has some method, some code of myself. As you can see, we have an A class, which has a crash method. This crash method, what it does is to change the method dictionary of the class and then sends an A message. So it will crash the image because the method dictionary is not a method dictionary. As you can see, it quits unexpectedly, and if we see the console, we have a bus error. That means that it is a segmentation fault. So let's do something more interesting. Let's say that by mistake, we actually saved the image with error. So we execute all that, and then when we try to open the image that we saved, which is broken.image, it starts, but then it crashes. So it doesn't even give us the moment to fix it. Let's see how with OS we can recover it. So we will open an OS recovery kernel. With OS. This OS recovery kernel, we have already prepared a workspace for the demo, but what we will do is to load a Faro image into an object space. An object space is a reification of an image, and then we will start to modify the objects just to fix it. So what we will do is we load the image, we get the processor scheduler, we can get the active process of this image as now, and then we can start inspecting the objects of the broken image. So we have a broken image and we can inspect it and modify it. So we take the active process and we ask for its context and to its method, and we try to decompile it so we can see the source code. So we see that the method that is currently installed in the image that it should be running is the snapshot method. So let's look at the sender. The sender of this method is actually the method that introduces the bug. So there we have a new crash, and some easy way to solve this is to change the a reference to nil. So instead of a crash, we get a does not understand. So let's see where is that A reference. If we look at the literals of the method, we see that it has 8 literals. So the save as selector, blah blah blah, snapshot and quit, crash. And in the 6th literal we have the A association. So let's look at the remote literals, not our vision from this side. We see that the 6th is actually an association whose key is A and whose value is an object. So what we have to do is to change that reference to nil. We see that that object is actually the class A from the other side, from the inner object space. So what we will do is to change the literal 6 to point to nil. We evaluate that, and after that we will rerun the image from this same process. So we rerun it, and we have the image that we had broken with a debugger open, which we introduced when changing the receiver of new. So we can actually save our image and recover all the lost objects and data that we had in there.